We have our function, which was y equals 4 over x plus 2. We're going to interchange x and y, and so we're going to get that x equals 4 over y plus 2. X equals 4 over y plus 2. And then, what do we need to do? Solve for y, always. Solve for y. Okay, well, this is a what kind of an equation? It's got a fraction in it. That's a hint.
Radical. No.
There's no radical here.
Fraction.
It's a fractional equation. It's got a fraction in it. It's a fractional equation. So what's your first step typically that you do to clean up fractional equations? Tyler? Multiply both sides by the common denominator, which is y plus 2, right? So multiplying both sides of this thing by y plus 2, we get y plus 2 times the x equals 4. And dividing by y plus 2, multiplying by y plus 2, you're going to lose the y plus 2's. Okay, so we get this. And don't forget, we don't want to lose sight of what we're trying to do here. What are we supposed to do here? Solve for y. So how do we solve for y? Probably distribute the x. And now here's the y right here now. So we need to isolate the y. So we're now going to kick all this stuff over to the other side. So we have y times x equals 4 minus 2x. And then we're going to divide both sides by x. And we're going to get 4 minus 2x over x. Okay, so we're reviewing the idea of forming an inverse. Starting with a function, which we know passes a vertical line test. And then we interchanged x and y. We identify this as a fractional equation. The technique for cleaning up fractional equations is always multiply both sides by the common denominator to get rid of the fractions. One step. Here it is. We now need to solve for y. So what we do then is distributed the x and move things around and solve for the y value. Any questions? Okay. So notice that this is a certain form. This would be called a general form of a rational function, wouldn't it? Linear function over linear function. Rational function. See it? And in its factored form, what would it look like? Help me. I know it's Monday.
2 on the outside of parentheses.
Pull a 2 out of the numerator. And so a factored form of this would be 2 parentheses 2 minus x over the common x. Okay? So there's your factored form. Here's the general form. And what if we took this and since it's a common denominator, and went ahead and imagined dividing this x up into the numerator? Look how easy it is to see right here. Isn't this a negative 2 right there? Negative 2. And then plus a 4 over x. So let me write it that way. Negative 2, the quotient, plus 4 over x. So there's the quotient form of this function. Can we draw a sketch of this? We should be able to. It's a rational function, linear over linear. And we have the different forms, so you can see the zeros and the vertical asymptote here. So if I draw it, we have a 0 at where? Where would a 0 occur? at x equals 2, we get a 0. Feel good? Vertical asymptote, folks. Where?
0, 0.
At x equals 0, dividing by 0 causes trouble, right? X equals 0. Vertical asymptote right there. And we label it. Okay, and then what else can you see? Though we just played with the factored form, and look at the quotient form. What can we see from that quotient form? Taylor?
An oblique asymptote.
Not oblique, but you're close. Y equals negative 2.
Or vertical. Or horizontal.
Thank you, horizontal. Y equals negative 2 plus, as large X happens, this heads towards 0. Let me write that down. If you're going way off to the right, then the Y value is approaching negative 2 plus this number, then 4 over a big number is close to 0, but slightly positive. So that indicates a horizontal asymptote, Y equals negative 2. Horizontal asymptote. A lot of people get mixed up by that, horizontal versus vertical. Think of horizontal as horizon. What do you see when you look out at the horizon? Nice sunset over the ocean. A horizontal line. Okay. So we have a horizontal asymptote, we have a vertical asymptote, we have a 0. So the picture, help me. You folks should be good at this. Picture. We know near vertical asymptotes they have to blow up or down, don't they? Okay, now we could do some testing like we've done previously. We could jump in. I didn't intend to have to reteach this today, but we could go in between a vertical asymptote and a 0, like some number between 0 and 2, like say, think of 1. Imagine putting a 1 in for x. Probably the factored form would be an easy spot. If you put a 1 in here, notice this numerator is positive and the denominator is positive if you're in this region between the vertical asymptote and here. So we're dealing with a positive divided by a positive, which has to stay positive. So blows up near this asymptote has to come through the 0. Now if you go out past the 0, out past 2, imagine putting a big positive number in for x. Big positive in here for x, what would you get? On the numerator, what's the numerator become of the big positive x? Negative, doesn't it? A huge negative value in there divided by a positive. Negative divided by positive out in that region to the right of 2 has to be negative. And you can see that the horizontal asymptote is the limit that this thing approaches as you move out towards the right, and so it ends up dying heading down towards there. If that looks like that, then what must occur over to the left? What would you expect to occur to the left? Where would you expect the picture to be? There's no zeros here. Down below here, good. And that's exactly right. The graph is going to look like this. Over to the left. Could you plot a point without having to do any algebra by even looking at the function, just looking at this picture we have? Could you help me?
Put a negative number for x.
Yeah, I don't want to look at the equation. All I want to look at is this picture.
So it's just the opposite. It's going to happen on the other side.
Where's this point going to be over here? It's going to be 2 to the left of the vertical asymptote, isn't it? Right? And then how far down is it going to be? What's this value going to be down here, folks? Look, if you're over to the right and you're up 2 off the horizontal asymptote, then it makes sense that if you go symmetrically over here, you're going to be 2 below this asymptote down at Negative 4. Let's check it out by looking at the algebra. If you put negative 2 into the function, that becomes negative times a negative becomes positive 4. Plus 4 is 8 over negative 2. 8 over negative 2 is negative 4. Okay. That is the picture of the inverse, isn't it? That's the picture of the inverse. Don't lose sight of what we've been doing. We started with some other function. We interchanged the x and the y, and we solved for the new y, and here's the picture of that thing. So this thing originally was called f of x. The original function was called f of x, and this thing is a function, isn't it? So we can use what symbolism? That's not f of x. No. F with a little negative exponent or superscript here. Okay? So this is f inverse of x, which happens to be this thing right here, which is 4 minus 2x over x. So this is an inverse function. That's the inverse function. Melissa?
Why does it look the same almost as that one?
That's the nature of a kind of a reciprocal function that's been transformed. A reciprocal function that's been transformed will have the similar character to the other one. But all the x and y's have been interchanged. All the x and y's have been interchanged. I like the camera image right now because it's got this picture right back here behind me on the screen. So keep the camera image where you are for a second.